You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of
Hello
Astronomy.
and welcome to
AFM
York
Radio,
Universe,
AFM
the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Sana, I'll be one of your hosts this evening, and I'm joined by Shatish, and for the very first time, Palvisha. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. This is Astronomy Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Head over to our YouTube page, York U Observatory, to join the chat. We will be monitoring the OPV chat room for questions and showing some archival images from our 1-meter telescope. It's raining tonight, so unfortunately we can't do any live imaging. For any questions or comments you have on our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @YorkObservatory and on Facebook at Allan I. Carswell Obs. So like I mentioned earlier, tonight we are joined by a new host, Palvisha, who you might know if you've been logged on to our OPV chat over the past few years. So before we get started, why don't you tell us a bit about yourself, Palvisha?
Sure. Hi, my name is Palvisha, and I'm a physics student here at York University. I've been with the Allan Carswell Observatory for several years now, and I'm excited to be a part of York Universe for the first time today.
Well, we're glad that you're here, Palvisha. It's always nice to have another host join us. So you and Shatish, you guys doing well?
I'm doing pretty well. It's really cold outside, but...
He should be able to define well. It's raining a lot here. I mean, yeah. I'm on the West Coast right now, so it's really raining, interestingly.
Yeah, the observatory has been trying to get new imaging software running. It was an interesting idea of using narrowband wide field cameras to image things, and they've been trying to do research using that system, but it's been so rainy and so cloudy recently that they haven't had too much luck. They've had a couple good nights, but nowhere near as much as they would want. It'd be nice.
Is that with the cameras that they've installed on the 60 recently?
Yeah, it's they have 2 cameras up there now, and they're these narrowband filters. And essentially, the idea is that if you use narrowband imaging or filters that only look at very specific wavelengths of light, that you can kind of bypass the light pollution problem in Toronto. And they've been working pretty well. The images that have come out of that thing are really great, but they've still been running into some problems with clouds. So the same thing, I'm sure Palvisha and Shatish and everyone, or and a lot of people listening, can relate to, setting up and then focusing, and then it gets cloudy and you can't do anything. And then the second you leave and go home, it clears up. So they've had some of those problems.
I still have one of my data sets, if you actually remember, Sana, that was so muddied with the clouds. And if we could have had like better observations or better data to, those were the first ones for the 1 meter. So I'm just trying to relate and actually narrate how frustrating it can be when you have clouds and then you have no clouds. It's hilarious. Anyways, ranting.
Yeah, it's especially frustrating when you're on a time constraint where you have a deadline for like a project or something.
Or like the project that we had in second year.
Yeah, where the only clear nights when Palvisha and I were in second year, we had to use the 60 centimeter for a project, and the only clear nights out of the entire year, the 60 centimeter broke because someone crashed it. So yeah, we got out of the entire term, there was only one night where we could observe, and that was our group, but we still couldn't use that data because there was a light leak that messed up all of our images. So that was an interesting semester.
I remember that.
Was that like which course was that? Second year courses, Professor
2017?
Marshall's?
Yeah.
Oh, 2070. Okay, yeah.
Yeah, it was the year right around when the 1 meter, when we were preparing for the 1 meter. So the 40 centimeter had been removed and there were renovations. And we were some of the first people to use the 60 centimeter after it came back online. So there were a bunch of problems that we had that night, and somebody had to stop by and like fix some problem with Dome Tracker. And then when we got that working and we started imaging, there was the light leak, and it was a mess.
And then the power went off in the whole building the next day.
Yeah. Yeah, so interesting times at the observatory. But anyways, we should probably get started with our This Week in Space and Astronomy history. So I'm the first one up for tonight with the anniversary of the launch of the Soyuz TM-31. So the Soyuz TM-31 spacecraft launched from Kazakhstan at 7:52 a.m. UT on October 31st, 2000, carrying the members of Expedition 1, which was the first long-duration crew of the International Space Station. For reference, we're now at Expedition 66. So this was a very, very long time ago. It was in the really early days of the ISS. The first components of the space station had actually only launched a couple years earlier in 1998. So the early days of missions to the International Space Station were really just centered around bringing up equipment and getting the modules set up and getting experiments set up. So prior to Expedition 1, for those 2 years, all of the crewed missions that went there were these short duration stays of just a couple days that were meant to deliver modules and other cargo to the ISS. But on October 31st, 2000, with the launch of the Soyuz TM-31, that changed. And ever since then, the ISS has been continually occupied for over 20 years now at this point. The Soyuz TM-31 docked with the, I'm probably not going to say this correctly, the Zvezda module of the International Space Station a couple days after it launched on November 2nd, 2000. Which also marked the first time that a Soyuz spacecraft had docked with the ISS. Previous missions had all been space shuttle missions. So this was the first time that a Soyuz was actually docking with the ISS. There were 3 crew members on board, 2 cosmonauts, and I'm apologizing in advance for if I mispronounce this. There were 2 cosmonauts, Yuri Jinzenko and Sergei Kirkolev, and then 1 American astronaut, William Shepard. The cosmonaut Yuri Jinzenko was the commander of the Soyuz flight, but then once they got to the ISS and Expedition 1 started, William Shepard took over as commander. Since they were the first long-term crew, they had a lot of housewarming tasks to do on the ISS. Their schedule seemed kind of packed and a lot of really interesting things happened during their stay there. So some of the things that they were doing was bringing life support systems, batteries, and communication systems online. They created and set up a computer network to run the ISS systems, and they also set up working areas and living quarters for the crew. During their stay there, they also had 2 Russian Progress cargo ships docking with the ISS, and then 3 other crewed missions, which were all space shuttle missions, docked with the ISS. They were STS-97, STS-98, and STS-102. STS-97 and 98 were both short-duration stays, which brought more equipment to the station, including the Destiny Laboratory on STS-98. Then STS-102 brought 2 crews up to the ISS. The first one was a 3-person crew, which would make up Expedition 2, and then a crew of 4 for a short-duration stay to help set things up. The Expedition 1 crew stayed on the space station for about 3 months. They returned to Earth in March of 2001 aboard STS-102 Space Shuttle Discovery. The reason that they didn't actually return with the Soyuz TM-31 and instead went back on the space shuttle is because at this time, the Russian Space Agency had committed to providing these lifeboats to the ISS. So they were just these Soyuz capsules that would stay docked to the space station. And if there was some kind of emergency or something and they needed to leave, the crew of 3 on board would just get in the Soyuz and leave. So it was their lifeboat, basically. But since the crew of Expedition 1 was only there for 3 months, the Russian Space Agency didn't need to provide a new Soyuz for another 3 months because they had only committed to supplying it or they committed to giving a fresh Soyuz every 6 months. So the TM-31 stayed docked with the ISS to serve as a lifeboat for another 3 months, and the crew of Expedition 1 returned on STS-102. The Soyuz TM-31 was replaced 3 months later, so after a total of 6 months in space, and returned to the Earth in May of 2001 after it was replaced with a new Soyuz TM-32 spacecraft. So that was a really interesting thing to read about, the first Expedition 1, the first long-term crew on the ISS. It's interesting how far we've come now, having so many people on the space station, and these earlier it was just a crew of 3. Okay, so I guess we'll move on to Shatish. You have our next history item.
Sure. Okay, so interesting stuff there by Sana. We will first talk about the date October 25th, as far as I can understand. And there's like loads of birthday shout outs, to put it bluntly, which probably seems like an interesting coincidence. And as we go along, we'll hear the names and we'll understand why they're important. So to begin with, we have Samuel Heinrich Schwab. And the year was 1789. He was born. He was a German astronomer who worked on sunspots. And he started off as an apothecary. I'm hoping I pronounce this correctly. Anyways, the modern name is a chemist or a pharmacist, probably. And he actually turned to astronomy a little later in his life. Actually, in the year 1826, he wasn't really too old. And he began to look for a planet inside the orbit of Mercury, which we know none exists. But, well, it was that time, and he did this for 17 years. So there was no planet. What he did actually notice was a regular variation in the number of sunspots. And he realized, he suggested there was a 10-year period wherein the sunspots actually reached a maximum in number. And that work of his didn't receive much attention except for, attention from Rudolf Wolf, who used to work at the Bern Observatory. And Schwab later on received a gold medal by the Royal Astronomical Society in 1857. So in those days, in those times, that was some really good planning work. The next further shout out is for Johann Friedrich Julius Schmidt. He was born in 1825. He was also a German astronomer, and he was also a geophysicist. He started as a selenographer, which is the study of moon, and he also served as director of the new National Observatory of Athens in Greece. And then he started making drawings of the moon, and somewhere around 1866, he made the claim that one of the craters, called Linnae, had actually changed in appearance, which didn't really, get accepted even until today. But since he was a noted, observer of the moon during his time, that was one thing that people did give some attention to. Anyways, later on, he finished a moon map sometime in 1874 and also discovered the Nova Cygni star in 1876. The Schmidt crater on the moon is named after him and 2 other people of the same name. The third birthday shout out would be for the year 1877, Henry Norris Russell, which most of us should be aware of as far as the name is concerned, especially the students. He was an American astronomer, and along with N.R. Hertzsprung, he developed the Hertzsprung-Russell diagram. That was 1910. He also worked with Frederick Saunders to develop the Russell-Saunders coupling, and he also co-authored a textbook in 1927 with Raymond Dugan and John Stewart. The book was called A Revision of Young's Manual of Astronomy, and this became a standard astronomy textbook for about 2 decades. Then there was Peter Noor. That was 1928. He was born as a Danish individual, I would say. Uh, he is a computer science pioneer and also a Turing Award winner. And the reason we are trying to mention him here is because he actually started as an astronomer. He has a PhD in astronomy back in 1957, I'm sorry. But later on, he moved on to this niche field of computer science. He contributed to creating the language ALGOL 60. And then with John Backus, he helped in describing the syntax for most programming languages. And then lastly, for this particular date, in the year 1935, precisely, we would like to wish a happy birthday also to Russell Louis Rusty Schweikart. Schweikart. And this gentleman is an American aeronautical engineer, a former NASA astronaut. He is also a research scientist, a U.S. Air Force pilot, and he was selected in 1963 for the third astronaut group at NASA. He was the lunar module pilot on the 1969 Apollo 9 mission, which was the first crewed flight test of the lunar module. And he performed the first in-space test of the portable life support system used by the Apollo astronauts who walked on the moon. So that's some pretty heavy stuff for October 25th. And happy birthday to everyone.
Is there something about October 25th? Because that's I think this is the most birthday shout-outs I've ever seen on York Universe for one day.
Well, that's what actually inspired this idea, and there must be something. I mean, you can't ignore the date. You can't ignore the.
Yeah, that's funny, but I've heard of several of these people before. Henry Norris Russell, of course, the HR diagram, and then Russell Schweikart. So I've heard of them. I don't think I've heard of many of the other people listed here. But yeah,
those were the pioneers, you know.
Yeah.
I don't want to say. I mean, yes.
Sorry?
Schmidt. We've probably heard of him.
Yeah, maybe, yeah. But yeah, it's.
I think we've spoken about the Schmidt crater sometime. We must have actually, so maybe because of that, one could reflect on the name. I'm not sure otherwise.
Yeah, Schmidt crater I've definitely heard of, but I'm not sure I knew who it was named after. But yeah, that's really funny. So many people on October 25th. Yeah.
Well, see, that's an interesting connection to your first item. We talked about loads of the STS missions, and then we talk about a date where there's been loads of astronomers. So I think we really are having a very heavy show today.
Yeah. All right. Well, up next we have Palvisha, who's going to tell us about the first pictures of the far side of the moon.
Right. So in 1959, the Soviets launched 3 major missions to the moon: the Luna 1, the Luna 2, and the Luna 3 missions. And they were all launched in the same year. And they were essentially the first set of missions ever made to the moon, completely unmanned. Luna 1, I believe, was just an orbiter, so it essentially was put into orbit around the moon, launched on January 2nd of 1959. Luna 2 was the first successful hard landing on the moon, so it was actually intended to crash land on the moon. And Luna 2 had basically discovered Earth's radiation belts, and it also measured the moon's magnetic field. And then the last Luna mission of that year was the Luna 3 mission, which was a flyby mission of the moon, I believe. And this was the mission where we actually received our first images of the far side of the moon. It was launched on October 7th, 1959, and the images were released by the Soviets on October 26th of that same year.
Yeah, the Luna program in terms of lunar history they took up all of the firsts of lunar exploration. So the Luna program is pretty interesting. Have you've talked about the Luna program at all in your history of spaceflight class?
Very briefly. So we essentially just talked about it in terms of like the context with like the Cold War and then the Soviets making their firsts with the Luna missions to the moon. But aside from that, there wasn't much that we've actually talked about in particular about the Luna missions.
But isn't it so that the Luna mission is one of the rare ones when it comes to anything about the far side of the moon? I think the only other people have been the Chinese who have had it. Yeah.
I think with what we've covered so far, I don't think there has been any other missions that have been brought up historically that have done like far side imaging of the moon until obviously the Chinese.
Yeah, I think wasn't there the Lunar Reconnaissance Orbiter, or there's been a couple orbiters that have mapped like 90-something% of the surface of the moon.
I know that.
No, go ahead, please, Patricia. I'm trying to find out more. Yeah.
You know, I know the Reconnaissance Orbiter has definitely done that. I don't think just like within that like timeline there has been any talk about.
Yeah, that makes sense.
Well, actually, correction here. So, 1962, they mentioned Ranger 4 space probe. It did become the first spacecraft to impact the far side of the moon. They didn't actually image it; it just crash landed there, probably. So, and then there's and there's more. There's probably Lunar Orbiter 5. I think that was a NASA mission. Lunar Orbiter 5.
Oh, which one was the other one that you said crash landed? Because I believe it was Luna 3. Oh, Luna 2 that crash landed in 1959.
Okay, so we have conflicting information now, but that's interesting. So I'm looking at Ranger 4's mention. It says it became the first space probe to impact the far side of the moon. So I don't know how, maybe the other one that you're mentioning is a different kind of mission because there's loads of firsts, and then I can find out more. Oh, okay, so the Chinese mission actually, so we're talking about the third mission now. The Chinese mission was this, I think, the first soft landing, if I can mention so. And then Chandrayaan in 2019 did take images, especially of the Jackson crater and poles of the moon, but it didn't land there. So it's not exactly that none of the others captured or entered the far side of the moon. But I think the Luna mission itself does hold a lot of firsts in itself.
Oh yeah, Luna 2 was the first hard landing. I think that's the difference there.
Okay. Well, they shout out for Luna 2.
Yeah. Okay, so we'll be moving on to another Soviet mission, which was Venera 13. It was mainly a lander that went to Venus, and the lander, of course, was meant to just land on the surface and collect data, while they had also a counterpart was a flyby spacecraft that was meant to fly by Venus and work as a communications relay back to Earth. Venera 3 launched on October 30th, 1981, aboard a Proton rocket from Kazakhstan. And like many other spacecraft at this time, it was launched with a twin spacecraft, which in this case was Venera 14, which launched a few days after Venera 13 on November 4th. A lot of both NASA and the Russian Space Agency or the Soviet Space Agency at the time, would launch spacecrafts in pairs, basically a couple days apart or sometimes at the same time, where it just kind of worked as an insurance policy because this was the earlier days of spaceflight and they were still kind of figuring things out. So there were a lot of mission failures, and they would end up launching spacecrafts in these pairs to make sure that if one of them failed, that you still had a second spacecraft there to go and complete the mission. So Venera 13 and 14 in this case were the twin spacecrafts that the Soviets launched within a few days of each other. Both of the spacecrafts had several instruments on board, including spectrometers, a panoramic camera, and a drill to sample the surface of Venus. Venera 13 landed on Venus after a few months of traveling on March 1st, 1982, on some plains in the southern hemisphere of Venus, which had lava flows and volcanoes. It spent the next 2 hours collecting and transmitting data from the surface, which actually surpassed its planned half hour of observations. I know 2 hours on the surface of Venus doesn't really sound like much, considering there are lots of lunar landers and Mars landers that operate for years, but Venus is a really horrible place. It's, yeah, I mean, I love Venus, but it really is a horrible place to be. It has a totally extreme, like, weather. It has an atmospheric pressure nearly 100 times that of the Earth, temperatures of like 400 to 500 degrees Celsius. So this is enough to melt lead. So, you know, you can imagine putting a spacecraft in that, it's going to kill your spacecraft in a relatively short period of time. So the fact that it lasted for 2 hours on the surface is pretty remarkable. But during the 2 hours that it was alive, it was taking data and transmitting it the whole time. It took 360-degree panoramic photos of the surface of Venus in color, and those were actually the first color pictures taken of the surface of Venus. There had been a couple Venus landers before that. I believe most of them or all of them were part of the Venera missions. The Soviets were doing a lot of Venus exploration at the time, I think more than NASA. But all of these previous missions had only taken black and white photos. So these images from Venera 13 were fantastic because they were the first color pictures and could be widely circulated. And then another thing that Venera 13 did was it took a soil sample from the nearby surface, which was another first for Venera 13. The photos that Venera 13 took of the surface showed that it had a rough area with lots of orange and brown rocks and some loose soil. And then the soil samples revealed that the soil and rocks on Venus were volcanic rock. And scientists also determined using some other data that winds on Venus had a speed of about 1 to 2 kilometers an hour, just based off of how quickly dust was landing on the lander. The flyby spacecraft, again, was mainly used as a communications relay, but another interesting fact about that is that it was used in an engineering test for missions to Halley's Comet. So it had some more implications beyond just Venera 13. The Venera 13 and 14 spacecraft were some of the last missions to land on Venus. They weren't the last. There were a couple more after that, but ever since then, there has been this really, really long gap between when a lander has been sent there. There hasn't been any landers sent since. It's really just been orbiters around Venus. But NASA does have plans to send another Venus lander coming up in the next maybe like decade or something. So that'll be exciting. But happy birthday to the launch of Venera 13.
Well, actually, a couple of things. So as far as I remember from the planetary science class, Venus definitely seems like a horrible place. When I say seems, that basically is saying if you try to image Venus, all the encounter are the methane clouds, if I'm not wrong. So it does look horrible. I am surprised that they did actually land and collected samples. I thought it was only like a reconnaissance mission or something. And then the other thing is it definitely has only been the Russians or the USSR, I think, at that time, who have even, like, it's only them. I think the US, like basically NASA did try something and they failed. And then I think it's difficult to even approach Venus as opposed to approaching Mars, which is why nobody even tries to spend money on that.
Yeah, Venus definitely seems like a much more difficult planet to launch a successful mission to.
And
Yeah.
maybe they don't have oil over there, so nobody wants to go there. That was a joke.
I believe the Venera images of Venus, Venus's surface, are the only images we actually have of the surface.
Yeah, as I know, I think, yeah, Venera was the only like series of missions that were ever sent by the Soviets. It was just the Soviets that managed to land, but they all kind of were under the Venera name, right?
Mhm.
Yeah.
Yeah.
Unlike
Yeah.
NASA, which launches like 3 different series of missions all under different names. Yeah,
Well,
the
you can't
going
forget STS. It's all the same name.
Yeah, but like going back to the Luna program, I think they're still planning on sending missions to the moon under the Luna name, like now, over 50 years later. So yeah, they get. I think they're a lot more dedicated to mission names than NASA is. Yeah, but we should be moving on because we're at 9:30 now. So Shatish, you have our next This Week in History item.
Sure. So this would be a short one, and I'm trying to make it short because I think I've been talking a lot. But it's again an interesting date, October 29th. We will mention not birthdays, but specific missions for specific things. 1991, October 29th, the American Galileo spacecraft, which I am pretty sure most of us, or all of us, actually have heard about. It made its closest approach to 951 Gaspra, which is an asteroid that orbits very close to the inner edge of the asteroid belt. And that made this mission, or this event itself, it was the first probe to visit an asteroid. And that is what the birthday shout out for this mission is about. Well, actually, for Gastra, maybe, or I don't know, something. And then 1998, October 29th, the Space Shuttle Discovery blasted off on STS-95. We literally really do talk a lot about STS missions. But this particular mission was special because it carried, with itself the 77-year-old John Glenn, whom we can also remember as being one of the pioneers of space flights in the history of human race, because he was one of the Mercury 7, the military test pilots who were selected in 1959 by NASA as the first astronauts ever, as far as NASA is concerned, or America is concerned. And then on February 20, 1962, John Glenn flew the Friendship 7 mission, becoming the first American to orbit the Earth, the third American and the fifth person in history to be in space. And then to add to that, he, with that mission in 1998, became the oldest person to go into space at that age. Although I believe the billionaires these days have been trying to break all those records, but I'm not too sure. But anyways, happy birthday to space science.
I know, I think it was a couple weeks ago, William Shatner, I almost forgot his name for a second. Because I don't watch, what show was he on? Was it Star Trek?
I have absolutely no idea. I think I remember him because of the fact that I did the news item I actually did the news item on the show, and that's why I remember his name now that you mentioned, but I have no idea otherwise.
Yeah, but he I think recently broke the record for the oldest person ever to fly to space, and that was only maybe like a month or two after I can't remember her name. She was one of the Mercury 13, which was NASA astronauts, or they never made it as far as being astronauts, but they were female astronauts who were applying to go to space, but NASA shot that down. So she finally got to go to space on a Blue Origin flight years later, and she held the record for a couple months as the oldest person in space. And then William Shatner came and broke the record again. So,
well, see, the funny thing is, both Shatner and the other person you're talking about, they're probably being remembered as like persons who were non-astronauts. And then John Glenn probably still holds the record for the oldest astronaut. I don't know why I'm taking sides, but just a fun fact.
Yeah, it was Wally Funk. I just looked her up. Wally Funk was the person who went on that Blue Origin flight a couple months ago. But yeah, I had no idea that John Glenn went to space again on an STS mission. It's really interesting.
Which is why we should do more of these shows, which we of course do.
Yes. All right. Well, we should probably move on to our last This Week in History item, which is back to Palvisha.
All right. So for the last This Week in History item, on October 27th, 1577, the Great Comet of 1577, which was also known as Tycho Brahe's Comet, or Brahe's Comet, passed through perihelion on this date, and it played a very crucial role in the understanding of comets. The official designation for the comet is C1577 V1, where the C designation essentially implies that the comet is non-periodic and isn't expected to return to Earth. So essentially, Tycho Brahe generated a series of observations of the comet as it was passing and determined that comets travel above the horizon. His observations also showed that the comet displayed no parallax and was an estimated 6 times away from the Earth than the Moon is. Until this time, it was thought that comets were exhalations in the upper atmosphere, which was an idea proposed by Aristotle. And this new conclusion essentially led to further investigations into the paths and behaviors of comets.
Is it not the same thing as maybe you just mentioned that, the Great Comet of, whatever.
I think there was a few great comets, because when I was looking up information about this comet, I came across several other great comets of different years as well.
Well, you know what? Tycho Brahe is remembered more than anybody else as one of the great astronomers. So let's just leave the title of the Great Comet with the Brahe Comet.
Yeah, there definitely are a couple great comets. Astronomers have always been bad with names, I guess.
I think that's what,
This one's non-periodic, so it couldn't have been repeated.
Yeah. Yeah, astronomers are not good at naming things. There's just this really cool comet. We'll just call it the Great Comet. All right. Well, for those of you who are just tuning in, you're listening to York Universe, broadcasting live from the Allan I. Carswell Observatory at York University in Toronto, Ontario, Canada. You're listening to Shatish, Palvisha, and myself, Sana, currently discussing some astronomy history. Go to observatory.info.yorku.ca to join the online public viewing chat room to ask us any questions you may have and to see some archival images taken by our observatory team. You can also connect with us on Twitter or Instagram with the handle @YorkObservatory and Facebook at Allan I. Carswell Obs. We have several interesting news stories coming up for you tonight, but before we get to that, we do have a couple of reminders. So first up, if you are interested in watching the Crew Dragon launches, there is one coming up this week on October 31st. It's going to be launching from Complex 39A at the Kennedy Space Center at 2:21 a.m., which is kind of annoying. But if you want to see it, you'll have to just get up in the middle of the night to watch that. I want to watch it, so I'm going to do that. I don't really know why. They're just fun to watch, I think, at least. But you can watch these live streams on either NASA's website or SpaceX starting at around 10 p.m. They cover crew ingress and a bunch of different things. So coverage starts much earlier than the launch at 2:21 a.m. A crew of 4 will be launching to the International Space Station. 3 NASA astronauts, Raja Chari, who's the mission commander, Tom Mashburn, who's the pilot, Kayla Barron, who's a mission specialist, and 1 ESA astronaut, Matthias Maurer, who's also serving as a mission specialist. So if you're interested in watching these Crew Dragon launches, keep an eye out for Halloween. I love that it's launching on Halloween. I think that's just perfect. But yeah, that's coming up a little bit later this week. And with the launch of Crew 3, the current Crew 2 mission that's on the ISS now is also going to be leaving soon. The date is to be determined, so just keep an eye out for that if you're interested in following that as well. And our next reminder comes from Palvisha.
Great. So we have our weekly teletube this Wednesday, as always. And in addition to this, we're now opening up the observatory for the first Wednesday of every month to in-person viewings. You can go to observatory.info.yorku.ca to get tickets to the November in-person public viewing, which will be released soon. Meanwhile, this week's teletube features York University's Professor Sean Tulin, who will be talking about the dark side of the universe, dark matter, and his research into it.
All right, perfect. So looks like an interesting teletube coming up this week. I'm definitely going to watch Professor Tulin. His research is pretty cool. But we should be moving on to our news stories at this point. I'm the first one up on that tonight with news of a new gamma ray telescope coming online in the next few years. So gamma rays are the most powerful kind of radiation in the electromagnetic spectrum. They're produced during certain kinds of radioactive decays and also during the most powerful events in the universe, like supernova explosions or neutron star mergers. There are currently several gamma ray telescopes operating in space, including NASA's Swift and Fermi telescopes and ESA's Integral Observatory, which was actually nearly lost this month when a charged particle hit a sensitive part of the spacecraft. But the Integral Observatory is still working well, so no need to worry about it anymore. But this week, NASA announced that we're getting a new gamma ray telescope in space. It's going to be the Compton Spectrometer and Imager, or COSI for short. COSI was one of 18 telescope proposals that was submitted to NASA's Astrophysics Explorers program in 2019. This Astrophysics Explorers program basically selects these small and medium class astrophysics missions that are designed to fill in the gaps basically between bigger missions like Hubble or JWST. It's a very successful NASA program. It's been operating since, I believe, 1958. It's launched over 90 small and medium class missions, including the Swift Observatory I mentioned before, and also the Transiting Exoplanet Survey Satellite, or TESS. And we've used data from TESS at the observatory for our variable star research. So there have been some really amazing missions that have come out of this Astrophysics Explorers program, and it's looking like COSI is going to be another one. COSI was selected as a small class mission. It has an expected cost of $145 million USD plus launch costs and is scheduled to launch in 2025 into low Earth orbit. So COSI really looks like it's going to be a fantastic mission. It's capable of doing imaging and spectroscopy in the 0.2 to 5 MeV range gamma rays using unprecedented spectral resolution for that energy range. The detector technology aboard COSI is, I believe it's some of the most advanced gamma ray technology that's been developed. It's been in development for years. It was tested through high altitude balloon flights, including one in 2016 where it detected its first gamma ray burst, GRB 160530A. COSI also has an incredibly wide field of view, which means that it's going to be able to complete surveys of the entire night sky every day. This makes it really perfect to look out for things like gamma ray bursts, which can help study not only gamma ray bursts themselves, but also is very useful for multi-messenger astronomy, where it can detect gamma rays from these events that emit neutrinos and gravitational waves, as well as electromagnetic waves. So COSI in particular is really good for this because it basically can do these huge surveys every day. And since we don't know when or where one of these multi-messenger events or gamma ray bursts is going to happen, you need to have something that just constantly monitors things. So COSI looks like it's going to be a perfect instrument for doing those kinds of observations. But apart from that, the main mission objectives for COSI is actually just to study gamma rays in the Milky Way. It's going to be looking at gamma ray emission from the galactic center and in the bulge of the Milky Way in more detail than has ever been observed before using its amazing spectral resolution. It's also going to look at the origin of positrons in the Milky Way. So those are just anti-electrons. They have the same mass as electrons, but just a positive charge instead of a negative charge. And finally, it's going to be looking into supernova remnants, and specifically where and when heavy elements in the Milky Way formed. It's going to do that last thing by observing several different radioactive elements, aluminum 26, titanium 44, and iron 60. So based off of all of these decays produce gamma rays when they radioactively decay. So by tracing those elements, COSY can kind of figure out where and when previous supernova explosions happened in the Milky Way, and from that can figure out how these heavier elements are produced. So I hope this does launch in 2025. I'm always skeptical of launch dates when NASA sets them, because it always seems a little bit optimistic, but COSY looks like it's going to be a really cool mission, and I'm definitely really looking forward to that, and hopefully it launches in 2025.
So I think I'm reading somewhere, well, actually not somewhere, it's the Berkeley's website. This is meant to look at sites of nucleosynthesis in these deep space, basically wherever galaxies were formed initially. And I think that makes it all the more interesting for people who actually work on, what's the term, galactic archaeology or something like that.
Yeah. Yeah,
I'm still learning, so yeah, I'm just talking, so go ahead, please.
Yeah, I did read that they were looking into some kind of nucleosynthesis in the Milky Way, but yeah, it looks like it's going to be investigating some really interesting things. And it's cool that we're getting another gamma ray telescope. When I was reading about this, I read about how this gamma ray detector technology works, and that's also pretty interesting, because it's slightly different than just using like normal optical imaging, because they're gamma rays. But the technology, it's like I think from what I understand, it's like they use these germanium detectors and they stack them. They have like an array of stacked detectors that they kind of trace back roughly where a specific gamma ray source came from. And then for each gamma ray, there's like a cone. It creates a cone on the sky from where it could have come from. And then when you have multiple photons or multiple gamma ray photons striking the sensor, you can kind of figure out where all those cones cross and where it came from. So that's I had no idea how gamma ray space telescopes worked before, like late last week, but that's it's pretty interesting. It seems like a really amazing technology they've developed for COSY. I hope they keep the name COSY too.
Well, that actually is an interesting name, and it relieves astronomers of not being able to set the right names for things in general.
Yeah.
And I think the way you've described, how they designed the gamma ray telescope or a detector, I'll be naive specifically, but I think I can try and relate this to a particle detector in general. But just at this time, it will be a particle detector in space, like not deep space, but space.
Mm-hmm. Yeah,
that's me. Yeah. So.
Yeah, it's pretty interesting. Yeah, I'm really looking forward to COSY after reading this. Not just because of its name, but it looks like it's just going to be a really cool mission overall. But we should probably move on to Palvisha. You have kind of two space news stories about the future of space travel, basically.
Yep, that's right. So my first news story is about a recent announcement. So this last Thursday, October 21st, NanoRacks announced that it, along with Voyager Space, will be partnering with Lockheed Martin to develop a commercial space station called Starlab. So Starlab will be specifically developed to meet the U.S. government, International Space Agency, and commercial needs for space. Starlab is supposed to be equipped with a docking node, a spacecraft bus to supply power and propulsion. It's going to be 3/8 of the volume of the International Space Station. It'll be equipped with a robotic arm, and it'll include an inflatable habitat, which is really cool. Along with that, it'll have the capacity to sustain 4 astronauts at a time, and essentially the goal with Starlab is to have it be continuously crewed and provide like state-of-the-art laboratory equipment to allow continuous research, but it's also going to serve use for tourism and just other business purposes as well. So in addition to this, earlier today, it was announced, Roscosmos announced that it deems that the SpaceX Crew Dragon is qualified to fly Russian cosmonauts. So after the end of the space shuttle mission in 2012, the Crew Dragon became the first American-made rocket to fly American astronauts to the International Space Station, and this happened in 2020. Prior to this, American astronauts were flown to the International Space Station on the Russian Soyuz spacecraft, and Roscosmos is aiming to bring an end to the Soyuz missions to the International Space Station by 2024. So if NASA and Roscosmos reach an agreement with the Crew Dragon rockets, it'll be the first time a Russian cosmonaut will be flying on an American spacecraft since the year 2006.
So much for peacekeeping, like really.
They flipped
I'm
places. It started with Americans using Soyuz, and now it'll be the Russians using Crew Dragon.
See, what goes around comes around.
It actually kind of sucks that Roscosmos isn't going to use the Soyuz anymore. It's just good to have two different ways of getting astronauts to the ISS instead of just relying on one.
Mm-hmm.
So yeah, kind of. I didn't know they were actually planning on bringing an end to the Soyuz missions.
Yeah, I had no idea either, but apparently they're trying to bring an end to the Soyuz missions to the ISS by 2024. So I guess it makes sense why they'd look for Crew Dragon.
Yeah, because I know the ISS is set to reach like the end of its funding by 2030.
About the same. Oh, is that 2030? I thought it was 2024. I don't know why I remember that date.
Yeah, well, it might be 2024. I just know that by the end of the 2020s, as it is right now, the ISS is no longer going to be funded. They might get extensions on that, so I don't really know what's going to happen fully, but the ISS has been up there for a very long time. So, and there's been a lot of stories recently about like cracks in the space station and other problems that it's been having. So I'm wondering how much longer it's going to last.
Oh, that doesn't sound good. I was hoping that they could extend the ISS because Starlab is supposed to be commercial.
Yeah.
We're probably going to be using it for just like basic like scientific needs, but it's also going to be used for like business and tourism.
Yeah. Yeah, commercial space travel is definitely cool, but I've always liked having some kind of government-run space program because all of the data is like released to the public and anybody can use it. You don't have to be necessarily a part of the project. So I don't know too much about this, but it would be kind of nice to still have some like international collaboration, something, some kind of space station.
Yeah.
But I also actually, sorry, go ahead.
No, I was just chiming in, to add to what you're saying. So you actually are right. It is 2030 till when the Space Frontier Act has decided to extend the operations of the ISS. And I am actually hopeful that human race will come up with a better, actually no, I wouldn't say better, but a new station or space station sometime. Because yes, you need to have something which is an international collaboration instead of just, what's the word, corporate collaboration?
Mm-hmm.
Yeah, I think they were also planning, I think the Artemis mission was supposed to put up a base in space as well. I completely forget what it was called, but I think they've at least for the time canceled that.
Yeah, Lunar Platform Gateway, was that
right.
it?
Yes, the Lunar Gateway.
Yeah, sorry, go ahead.
Oh no, yeah. I think they've like momentarily either like put it on hold or have deprioritized it from the mission.
Yeah, there's been some like drama, I think, around that. I know that they have the Artemis 1 where they've completed the spacecraft or something for Artemis 1. but I know there was some issues where I think Roscosmos was thinking of pulling out of an international collaboration for Lunar Platform Gateway. So I don't really know what's going on with that, but it would still definitely, it would be really nice to have some kind of international collaboration for that. I don't know. It's just, I always think that it's nice when people work together because it's just so much easier to accomplish things when you have everyone working together to do something than it is just NASA or just Roscosmos.
Actually, there are quite a few lined up. I'm not sure if they will count as international programs, but there's the Lunar Gateway, which will be a collaboration between NASA, ESA, and the Canadian Space Agency and JAXA. I think that's the one you're talking about, Artemis.
Yeah.
Right. So actually, that's the only one which is truly international. The others are just something. But there's loads of them coming up anyways.
Yeah, I'm reading about some of the Artemis planning, and it's like, oh yay, we're going back to the moon finally. It's really exciting. It's been way too long.
It's time we actually got a seat on the moon finally. Like we sit there and sip coffee or whatever.
Yeah, and the Canadian Space Agency has seats for not the landings on the moon, but just for the orbits. I think they have 2 seats on Artemis, like 1 seat on Artemis 2 and 1 seat on Artemis 3 or something. I'm not sure, but I know Canada will be sending somebody in lunar orbit.
That's going to be exciting.
Mm-hmm. All right, we have a couple minutes left. Shatish, do you have a third a third news item for us?
I do have, sure. And also quickly, I would like to mention, since we were talking about the definition of the Great Comet, just to point out, there's actually a proper definition and there's loads of great comets that we've had. And there is a reason for the definition, which I'll not get into. But I just wanted to mention that we were talking on the right track. So we'll talk about the news that I have as of today, as of right now, and I hope people find it interesting to some extent. So this is a new one, like really new one, and astronomers actually think that they have discovered the first planet outside of a galaxy. So I actually read this twice before I thought it was a good news item, because it actually mentions galaxy, doesn't mention solar system. And the source seems to be data from the Chandra X-ray Observatory, which has been working on exoplanets at greater distance than ever before. So the possible exoplanet is a candidate which is located in Messier 51 or M51, which we also know as the Whirlpool Galaxy. And then this is supposed to be around 3,000 light years from Earth. Well, 3,000 light years was the farthest we had found. An exoplanet in M51 would actually be 28 million light years away. Which I'm not even sure why we're looking at an exoplanet that far, but if it really is a planet which is habitable and all sorts of things, well, no distance is too far. So the Harvard and Smithsonian Center in Cambridge, like for astrophysics, which is where the researchers and the scientists are looking at. So they've been searching for planet candidates at X-ray wavelengths, and which is a better strategy that makes it possible to discover them in other galaxies instead of just, spending time around looking in our own galaxy. And based on transits and how the starlight is blocked in front of a star's light, that's the usual method of finding out or for looking for exoplanets. Now, because the region producing bright X-rays is small, a planet passing in front of it could block most of or all of the X-rays, and that the transit becomes easier to spot. So one could find more information on loads of articles, but that was one piece of information or one piece of news that I did want to talk about. All from me.
All right. Well, that is perfect timing because we're almost out of time now. Hello, everyone. You've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Shatish, Palvisha, and myself, Sana. Stay tuned because it's Astronomy Night in Canada. Coming up next is Western World, Quirks and Quarks, and Science for the People. You can always stay connected with us on Twitter with the handle @YorkUniverse and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good